Section 10.1, Acids and Bases. In Table 1, we look at the properties of acids and bases. Acids have a pH of less than 7, while bases have a pH of greater than 7. For acids, electrical conductivity varies. So does the conductivity of bases. Acids have a taste that is sour. And remember, never taste chemicals in the lab. Whereas bases have a taste that is bitter. Acids have no special feel, whereas bases feel slippery on the skin. Never touch acids or bases in the lab, especially if they're labeled corrosive. Now, acids and bases have different properties based on how they react with acid-base indicators. For example, bromthiamyl blue is yellow for acids and blue for bases. Phenolphthalein is clear for acids and pink or fuchsia for bases. Methyl orange is orange for acids and yellow for bases. Litmus is red for acids and blue for bases. In neutralization reactions, acids neutralize bases and bases neutralize acids. Let's look at the reactions of acids. Number 1, acids react with metals above hydrogen on the activity series to produce hydrogen gas. For example, magnesium metal plus hydrochloric acid produces magnesium chloride plus hydrogen gas. Number 2, acids react with carbonate compounds to produce carbon dioxide gas. Calcium carbonate plus hydrochloric acid produces calcium chloride plus carbon dioxide gas plus H2O. Now let's look at the reaction of bases. Bases react with carbon dioxide gas to form carbonates. Calcium hydroxide base plus carbon dioxide gas produces calcium carbonate solid and H2O liquid. Number 2, bases also react with oils and fats to produce soap. If base comes in contact with your skin, it feels slippery because it's reacting with oils on your skin to form a soap-like mixture. Let's look at the nomenclature of acids. This should be a review. You can tell that a compound is an acid if it's in a chemical formula, starts with one or more hydrogen atoms. We would add the state aqueous because most acids show their acidic properties only when they are dissolved in an aqueous solution. Acids without oxygen are formed between hydrogen and a nonmetal. The names of acids without oxygen start with the prefix hydro and end with ic acid. For example, hydrofluoric acid, hydrochloric acid. Acids with oxygen are called oxyacids. If the oxyanion name ends in ate, then the acid name ends in ic acid. For example, nitrate ion forms nitric acid. If the oxanion ends in ite, then the acid ends in us acid. For example, nitrite ion is called nitrous acid when dissolved in water. Naming an acid that includes oxygen. Sample problem. Write the name of the acid with the formula H2SO3. Start at the top of the flowchart in Figure 6 and establish whether oxygen is present. In this example, oxygen is present, so this is an oxyacid. Number 2, identify the oxyanion. In this case, the oxyanion is SO3 2-. This is the sulfite ion. Establish the name of the acid from the name of the oxyanion. The acid with the formula H2SO3, remember if it's a sulfite ending in ITE, we end up with OUS acid. In this case, it would be sulfurous acid. Writing the formula of an oxyacid. Write the chemical formula of bromic acid. Use the name to identify the type of the acid. Since the prefix hydro is not present, then it must be an oxyacid. Use the stem of the acid's name and any prefixes or suffixes in the name to determine the oxyanion in the acid's formula. Bromic acid implies that this came from an ATE oxyanion, which is bromate. BrO3 minus. So we are going to combine this with hydrogen. And we're going to crisscross to get the formula H1BrO3 which is HBrO3 aqueous. The formula for bromic acid is HBrO3 aqueous. Now let's look at naming bases. The name of a base is the same as the name of the ionic hydride. For example, name the following base, MgOH2 aqueous. We would name this as magnesium hydride. Please read over the section, try any practice problems, as well as any LMS quizzes on this section.